All right, let's get started. Welcome everyone to this Business Finland webinar on smart mobility. This is our second session on the smart mobility series, following the live stream we did yesterday with the topic of why Finland is a top location for automotive R&D, even though we don't have any consumer brands of family car manufacturers there. And the premise is that there is, instead of those large, well-known OEMs, it is a tight concentration of software, hardware, and user experience know-how that's currently serving the international legacy industries, and automotive being one of the most prominent one. Today, we're discussing one of the fantastic examples of the type of quick and agile projects that you can do with a multidisciplinary, multifaceted team that is so typical to the Finnish R&D scene. Before we get there, let me review the house rules for the webinar today. During the presentation, you will be able to type in questions in the Q&A field on your GoToWebinar panel. You can choose to be anonymous, or you can leave your name and the company. At the end of the presentations, all of them, I will read your questions to the speakers, and hopefully we'll get a good panel discussion and conversation going. I will not be reading your name and a company. That will remain with us in case you'd like us to contact you for further information. The session is recorded and a video will be made available. All right, without further ado, let's get down to today's agenda. We have a total of 5 speakers today. They each played a different but critical role in designing and creating the Origo steering wheel. We're going to start with, We're going to start with Professor Roope Raisamo from Tampere University. He is the head of Tampere unit for Computer-Human Interaction faculty of Information Technology and Communication Sciences. So he's going to lay out the umbrella of how Tampere University made this concept project possible. Now, following Professor Raisamo, we're going to hear from 3 businesses that actually were the ones creating the concept. We're going to start with Ms. Mari Makkonen. She will do an introduction to the 3D Touch. She's the marketing director of CANATU, which is the material science company with the carbon nanobud sensors that were used. Then after Roope, we'll hear from Hasse Sinivaara. He is the senior technologist responsible for design innovations at TAUCHI Group, and TAUCHI is the company behind the injection molded structural electronics.
Hi, Petra, can I disturb you for a quick second? We have a question. Somebody's saying they can't hear you, so I just want to make sure that everyone else can hear you.
Can everyone hear me?
We can hear you.
Right, okay. Nicole, are you there? Can you type in if you can hear us? Anyone else? Okay, maybe Harlan, if you reset your browser. All right, where was I? So I introduced Hasse Sinivaara from TAUCHI. TAUCHI is the injection molded structural electronics company. And then the third business, okay, let me see. Yeah, Nicole, you can hear us well? Okay, very good. So yeah, Harlan, if you want to just reboot your system. All right. TAUCHI, the injection molded structural electronics company, and then he will talk about the user interface. Hasse will be followed by Mr. Timo Posio. He is a business development manager from Siili Auto, and that is the user experience on top of the UI. And after the 3 businesses, we're going to wrap up with Dr. Ahmed Farouk. He is a postdoctoral researcher and a visiting postdoctoral fellow at Purdue University, and he will kind of summarize the industrial university collaboration. All right, now Professor Raisamo, go ahead and share your video and your screen. And I'm just gonna take out my.
I'm waiting for the share.
All right.
Okay.
You got it?
Should be now visible.
Yes.
So, hello. As Petra said, my name is Roope Raisamo. I'm from Tampere University, and I'm heading TAUCHI Research Center, which is the largest academic research center in Finland in the field of human technology interaction. Tampere University is the second largest university in Finland. And in addition to world-class research, it is well known of active industrial collaboration, where it ranks as #1 in Finland. Now, some details about the project that is today presented to you. First, I want to say that it's a co-innovation project, as you see in the heading. And this is a typical university-industry collaboration instrument in Finland. It means that there is close collaboration and co-creation as an integral part of the project, and the results of the university will be public and published in academic venues, but companies will keep their results that they are producing. The project is called Multimodal In-Vehicle Interaction and Intelligent Information Presentation, or MIVI. In addition to the university, we have 11 companies collaborating in this project that runs until summer 2021. It is a major research program funded by Business Finland with a total budget of 8.5 million euros and including public R&D funding of 3.78 million euros. In addition, this project is collaborating with 3 US universities, including UCSB, Purdue University, and Bentley University. And we have actually already implemented 2 research exchange visits for longer periods with 2 of these universities. But unfortunately, the current COVID-19 situation will likely cancel the rest of these visits in this project. About the ecosystem that we have in this project, in the center of the figure, you see here companies that are funded by Business Finland and university, of course. And in the next layer, we have our partners from the project that are providing in-kind contributions, something like windows or data or systems that we can use in the research. Then in the next layer, we have some other Finnish companies that are related to this field and potential partners. And in the outer layer, there are international companies that are very often clients for our partners. Then briefly about the content and what is the motivation for this project. There is increasing traffic and complexity in car systems, and this may lead to safety issues and, of course, many other usability problems. For example, the driver should not look off the road for too long when using touchscreens or other car displays. Environmental noises may render audio less useful, and there is always some vibration and forces involved when driving with the car, and this affects the sense of touch and any haptic feedback that might be used. Our solution is to study multimodal in-vehicle interaction that is making use of different human senses and natural ways of human action. And these latter ones include things like speech, gaze, gestures, and touch, and that kind of human actions. Then about the other part of the project, intelligent information presentation. Currently, there is really plenty of data coming from car systems, and of course there is many kind of sensor data related to traffic and any other kind of data that is used in the car, like internet or any other service that you want to use during driving. Also connection to other people. And we have this low-level data, and then we are using artificial intelligence methods to understand this data better to make it higher level presentation. And then we adaptively present this car information and external information to the driver and passengers based on what they need and what is recommended for them at the given situation. And use of this interaction modalities is adapted to the driver and context, and we can accommodate abilities and preferences of the people driving, like if somebody has lower vision or something else, some other problem with the senses, we can compensate that with some other modality that is useful for that person. Of course, the driver should be seeing quite well, but the passengers may have some other situations. Then I keep my introduction very short. So next you will hear about a high-profile result that is presented by several companies and one of our researchers. And I'll just leave it here for Mari to continue.
Thank you, Professor Raisamo. All right, Mari, I will make you the presenter so you can start sharing your slide. Excellent, thanks. Go ahead. Hold on, you're muted. Oh, can you unmute yourself? I can't unmute you. Okay, I think.
Yes, now.
Okay.
So hello, everyone. Before we start with Origo, I would like to say a few words about CANATU. So CANATU is a materials company, and we've invented a new carbon-based material that we are applying to benefit the automotive industry with 3D touch sensors and heating elements. So with our technology, virtually any surface can be made smart and functional. And in this concept, we are enabling intuitive user experiences with 3D touch surfaces integrated into the steering wheel wings. So one of the leading ideas behind the Origo steering wheel concept was to bring the intuitive smart device user experience to driving. In Finland, we have a lot of expertise in designing intuitive and ergonomic user interfaces for the consumer electronics. And typically these devices are used with thumbs, but the car industry has done this differently. There's typically a separate center display to control the functions. So the driver has to take his hands off the wheel and eyes off the road to adjust the climate controls, make a call, or use the navigation system. And this is, of course, causing a lot of distractions that can have devastating consequences, as it only takes a moment for an accident to happen. So we wanted to help the automotive industry to minimize distracted driving by adapting the strengths of the smart device interaction patterns to driver controls. Then we also wanted to offer driver a bit of clarity with our steering wheel concept. Our lives have become so cluttered with information, so we wanted to avoid overstimulation by reducing the functions and controls to the bare necessities. So the Origo steering wheel concept is a perfect combination of inspired design, novel 3D touch technology, and leading-edge software. With the new 3D touch steering wheel, driver can manage all key functions with their thumbs without letting go of the steering wheel. So it improves safety by minimizing distracted driving. Instead of touching on screen with the index finger, the driver can keep hands on the wheel and eyes on the road while controlling the functions. And the key controls are placed on the steering wheel wings and easily accessible within thumb reach. driver can perform many tasks with a simple tap, scroll, or slide. For instance, zoom in or out of the navigation map by sliding both thumbs horizontally at the same time on top of the touchpad, or adjust volume by scrolling thumb at the edge of the left scroll touch area. Origo features this iPod-like scroll wheel that is 3D form, so it's very intuitive to use even without looking. So all in all, these thumb-based touch controls are very familiar for billions of people that are using smart devices daily with their thumbs. So these 3D touch surfaces enable design freedom and intuitive user experiences. The CMP-based touch sensors are extremely stretchable and flexible, which means they conform to any three-dimensional shape. You can replace multiple mechanical controls from different cockpit locations with the 3D touch surfaces, enabling sleek and unobtrusive interiors. And thanks to the expressive forms, they can be operated so instinctively that the driver don't even have to look at them. And finally, I am extremely happy to share that our jointly developed concept has been awarded with a winner prize in the German Design Awards Excellent Product Design Human Machine Interface category. And we are all, of course, very proud of this recognition, as it's a concrete proof of the level of innovation as well as the capabilities of our technologies. So with that, I would like to end with a brief animation that will give you a sneak peek on what the concept is all about.
Thank you, Mari. Let me activate the sharing. Wonderful. Thank you, Mari. That was very exciting and very cool, and congratulations on the win. Next one, I am going to promote Mr. Hasse Sinivaara as a presenter, so you can start talking about the user interface. There we are. Can we see your video? There you are. Go ahead. Oh, you're muted. Can you unmute yourself? For some reason, I can't unmute you.
Okay, now.
Okay.
Should be ready to go. So, hello everybody. My name is Hasse Sinivaara. I'm representing TAUCHI, part of the MIVI Origo steering wheel consortium member, and mainly, let's say, I'll just try to put it in a presentation mode.
Yeah, that's good.
So,
Thanks.
I work as a senior technologist in design innovations, which practically means I'm spending 99% of my working time with OEM styling studios, UX people, color material finish people, as well third-party styling studios around the globe. So what TAUCHI is doing, we develop a injection molded structural electronics technology, which enables so we integrate technically a printed electronics with a semiconductor or chip-based electronics into a injection molded structural parts, which means it's ultra thin, natively 3D form, what we call as a smart surface, integrating touch, gesture, connectivity, and illumination. So it's technically a single piece HMI solution for various industries, various use cases, and so forth, so on. And within the Origo steering wheel, I've been working basically for kind of from UX to UI logic definition, as well the illumination architecture based on the technology combination we've used with CANATU CNB films together with our IMC technology to basically create a very unique solution, something that cannot be really reproduced with any, let's say, competing technologies, conventional technologies in this form factor. So in total, as you can see, the exploded view layout, but actually the functional element is at about 4 millimeters thickness only, and within that we basically carry the touch technology by the CNB film, as well the illumination within the IMSC part. So it is a ultra thin, natively 3D part, and carries all the functions. So like I said, we tried to create a something that is not reproducible with any other competing technologies within this particular form factor and the feature set. And if we go back to the philosophy of the UX and the UI, it goes way back to, let's say, 50% from my background of being a motorcyclist. I lived in Silicon Valley and Southern California for 6.5 years, ways back, observing the traffic. As you do with the motorcycle, you do observe a little bit differently. So it's pretty remarkable what people actually do within the car while they drive, whether it's with their phones, whether it's with their touchscreens, or any other, let's say, user interfaces within a vehicle. So very enlightening experience, which we kind of carried into this project. So another kind of like Mari said already, that we tried to create something that is substantially reducing the interaction time within any media screens within the vehicle. So tangling with touch screens and so forth. So another kind of in that context, how to come up with the solution was really to look at what is the most natural, and I came back to the PlayStation like UX. So you have a remote controller and then you have the visual feedback. So technically you don't really look at the remote controller, but you follow the visual feedbacks, and that's kind of the essence of the design that we created a HMI, physical HMI system, such that you don't really have to gaze in or look into it, but you can operate it with fairly intuitively without any visual following of what you do, but you get the visual feedbacks from the displays, and better yet, if you have the head-up display, so that's kind of reducing the absolute interaction with any other screens in the vehicle. And then about the HMI system itself, like I said, it's a PlayStation analogy. So you are remote controlling most any function within the touch zone areas, and it combines the iPod scroll wheel user interface as well the smartphone gestures by tapping and swiping functions. So it is something that is very intuitive. It is something that people are accustomed to. Few very kind of a unique and new features. Those left and right zones are actually user configurable. So you can flip the side. So in definition, the left side here is basically your adjustment side. So you adjust volume, temperature, fan speed, etc., on the scroll wheel. While the other side on the right side is basically your menu browser. So we can actually change those sides by just going to the settings and selecting the profile 1 or 2, and you can switch the sides. So you can, based on your handedness, based on your, let's say, driving preferences, or if it's basically a UK-based car or European or American-based car, you can configure the zones to be swappable between each others. Another unique is something that you can actually define your own gestures if you like. So it is a departure from a traditional OEM-defined user interface where you have, volume is on the left side and something on the right side, and there's actually absolutely nothing you can do. But here you can actually define your own gestures, so you can adapt the user interface into your own preferences. And if there's multiple users for the car, it's always adaptable for the user itself. Another kind of a unique first ever, as we know, is the full navigation and maps control directly on the steering wheel. So those multi-touch zones, we can control the navigation. We can type in the characters. You can operate the maps, zoom in, zoom out, or do the map orientation. So up until we know, there's no implementation or even the concepts existing in this level within the steering wheel system. And lastly, we actually implemented few of the capacitive ASIL safety features. So it's a discussion what I've been going through with multiple UX people within, let's say, within automotive domain, virtually with any OEM, is the question of, can we actually do safety-related functions with capacitive technology? And here we kind of introduced a logic that is based on the swiping elements in the touch zones. We have the grip detection or hands-on wheel detection in combination as well, the user interface, the GUI logic. So it is designed to be a discussion opener within the OEM segment that, okay, can we actually do capacity-based ASIL functions within a car, whether they are in the steering wheel or elsewhere in the car, but nonetheless, functions, cruise control, start and stop function, and the turn signals are basically the ASIL functions we integrated here within the capacity domain. And lastly, the illumination architecture is something, as you can see, we have a transparent windows. I call them as a glow rings. So technically, we created this for the purpose that, yeah, it looks cool on a let's say a demonstrator, technology demonstrator, but on a second level, we could consolidate basically informative warning and styling lights into those rings as such. So technically, you have multiple different warning lights within a vehicle today, whether they in an IP cluster or let's say a dead spot or blind spot monitor warning signal in the mirrors outside. So you can actually bring them into the steering wheel, which is technically always within your very kind of almost like a focus field. So that's the reason why we also created this illumination architecture for for trying out that can you consolidate the lighting features in the steering wheel. So that's in a nutshell about the UX UI, the HMI logic behind the Origo system.
Thank you, Hasse. That was incredibly fascinating. We have a few questions coming in, but I'll take all the questions at the end of the last presentation. Okay, from UI to UX, I'm gonna make Timo Posio now presenter, so you can start sharing your. Okay, we can see the presentation. Can we get your face as well? If you don't mind turning on your video so we can see. There you are. All good. Go ahead. Oops. Nope. Audio. Can you try? Now.
Yeah. Okay. So hello everyone. I'm Timo Posio from Siili Auto as a business development manager and coming from Siili Auto's Oulu office from Finland. So first, briefly about Siili Auto. So we are a professional services company focusing on the HMI innovation and HMI development. So on the HMI innovation side, we are working with OEMs and tier ones, with especially with the design departments what comes to rapid prototyping, helping the design teams there. And for example, we have been working lately with Pininfarina, and also this Origo steering wheel is one example of the innovation part. And then we are also working with production cars with tier ones and OEMs, and those start to be close to 3 million vehicles on the road where we have contributed to the development of the digital HMIs. And just a brief overview. So we are in Siili Auto, we are operating from Finland. Then we have R&D centers in Poland. Also, we have operations in US in Detroit as well. And have been working with the major OEMs tier ones since 2013. Then going to the Origo user interface. So our contribution to the Origo steering wheel has been the actual digital user interface design and implementation of the UI software. First, going to the user interface design. So there's been two basic principles, and this is actually going from the logic that Hasse presented to the actual details. So the first principle was how to reflect the physical design of the steering wheel to the user interface. And there's one example like this wings, how we call them, how those are reflected as these black panels in the user interface. So that brings seamless user experience and seamless feeling how those that digital user interface works together with the steering wheel. The other main thing in the UX design was that how the visual appearance of the user interface matches the UX logic, what Hasse was telling about. And there are two examples shown here. So the one is the like adjusting the volume. So there we have this circular component which directly follows when you adjust the volume with your left thumb in this case. So directly follows your thumb movement. And the other example is then on the right side here is this playlist. So these menu lists and this playlist what is shown here, these are shaped in the curved form, also resembling this circular movement that you can do with your thumb and adjusting the controls there. So those have been the main principles when doing the actual design of the user interface there. And then when going to the implementation, how the software has been built. So basically, this is already now automotive grade implementation. So there are already this standard cluster elements included in the design and implementation, telltales, and also these ASIL elements, what Asse mentioned. Then the software is built on the widely used CANAT platform that is being used by many OEMs there. So we have been using the CANAT UI framework, CANAT Connect as a middleware layer, and then also CANAT Maps as showing the map information there. And finally, the actual hardware where the software running is automotive grade IMX8 hardware environment there. So that's sort of creating an excellent basis for actually utilizing directly some of the components and implementation what has been done with the Origo steering wheel. Okay, that was my part.
Thank you, Timo. So that was the last one of the three businesses that were part of creating the steering wheel. And I want to mention as well, you spoke about the Kansi platform. So that's provided by Rightware, another Finnish company that was on Mari's slides. So that concludes the businesses. Then we're going to have Dr. Farouk still wrap up with the industry university collaboration. Okay, I got. You are unmuted and we can see your screen and your video is there. Okay, you should be. But we can't see your presentation.
So is everything okay? Can you see my presentation now?
We can see it, but it's on a split screen. If you don't mind going to your settings and adjusting it so we can just see the one full presentation. Now it's good. Go ahead.
Okay, great. Thank you. So like Petra mentioned, hello. I'm Ahmed. I'm a researcher at Tampere University and part of the MIVI project. I'll be discussing the industry-university collaboration with the Origo steering wheel concept. So Finnish industry and university collaboration provides the opportunity to evaluate and fast-track novel research ideas to develop functioning prototypes. The MIVI Origo concept is a prime example of this collaboration. Using streamlined techniques, we've been able to create novel systems to further research and development in multimodal in-vehicle infotainment and interaction environments. Some of this research includes breakthrough ideas in user interaction and system design, as we've already discussed, including this new concept called embedded haptic waveguides, which transforms the surface of interaction into an actuator itself. Unlike traditional collaborations where usually swayed towards either basic research or marketing a specific industry asset, the MIVI consortium values a well-rounded approach towards novelty in design and the practicality of execution. We've been able to achieve this through a sound development framework. The collaboration framework for the Origo concept utilizes various methods to get the maximum results. Using ideation and concept development through collaborative design and prototyping within a targeted working group, the joint team has been able to fast-track multiple generations of the Origo design concept. Remote testing and versioning has helped the team to overcome current issues with respect to the global pandemic, while system integration testing and user experience testing will help us evaluate the system more efficiently and provide a concrete output to this collaboration. As mentioned earlier, the collaboration also has yielded further interaction with our academic partners from around the world. Specifically, we've had various research visits with our long-term friends in the US and Canada during this project. Additionally, our research output is actively being presented and published in various venues to help develop and promote the new research in multimodal in-car interaction for Level 2 and Level 3 autonomous vehicles. Here's a short 30-second excerpt from our User Interface Software and Technology 2020 conference submission, discussing the novel concept of the 3D printed embedded haptic mediation I mentioned. After this video, we're happy to answer your questions. Thank you.
Thank you, Dr. Farouk. So I'm gonna share the video from my end.
Thank
So
you.
bear with me. It should be.
We propose a novel method of solid haptic mediation. We achieve this by constructing multiple embedded haptic waveguides within the surface of interaction, which can effectively mediate a specific range of applied signals. Here, the solid material acts as the waveguide, while the empty space provides an insulation around the waveguide, reducing the unwanted propagation of the signal. This technique reduces unnecessary energy dissipation and guides the applied signal to the point of contact.
All right, thank you. So what I'm gonna do now, let me turn my video, is I will pull up all the presenters and I will be pulling up some of the questions. We have a number of questions from the audiences. So it looks like, okay, if you can turn on your videos yourselves, that would be helpful so I don't need to click the, apparently I have to send a request. Excellent, everyone is here. All right, we got questions pouring in. The first one, I think this came, Mari, during your presentation, and the question is, what about false activation on the steering wheel controls? Can you unmute yourself? I can't unmute you. Again? Unmute again.
I can help.
Yeah, please answer. I don't know what's going on with Mari's mic.
Okay, well, let's say in a zero state, the steering wheel is basically in your standard menu. So the other one, let's say the left side is basically your menu adjuster, and the right side is your left side is your volume adjuster. That's basically the zero state. So the right side is the menu adjuster. So let's say if you by mistake you tap something or you basically touch something, you technically travel only within the menu, or you tap the menu or you tap the volume, but technically you don't adjust or you don't activate any function in the vehicle in per se.
Do you want to add anything, Mari, to that? Oh, sorry.
So if you basically, let's say by accidentally you hit the cruise button, yes, it activates the cruise, but you cannot adjust without a certain safety logic behind of it. So technically you cannot adjust any cruise functions. And then if you tap the home, basically that takes the vehicle to the home zero state. So volume adjuster and the zero menu state. So there's a whole lot nothing you can actually do incorrectly in that UI in that sense to activate the vehicle logic.
Anything to add, Mari?
No, not from my side. I think it was well explained by Hasse already.
Okay, good, cool. And thank you all for very detailed presentations. I want to get one of those steering wheels immediately. Okay, next question is it planned to run an HMI study with Origo steering wheel versus established steering wheel switch and UI designs? Who's going to take this one?
Maybe I can answer. So it's the plan to study these company-driven prototypes in our academic research, and that's actually when Ahmed is collaborating with the companies in the near future, we are planning some studies based on this.
Yeah, if I may add, we have couple vehicle OEMs that actually are interested to integrate the steering wheel into their let's say a prototype vehicle, which would then mean that we would actually be driving with the steering wheel, and we would be bypassing some of the functions on the vehicle canvas itself. So we could actually test, for example, the cruise controls, turn signals, and other ASIL functions. So there is a possibility that at the later phase there is a real car UX testing as well.
Yeah, I have a follow-up question on that. So this is a concept design and it was created together with the university, but who legally, who owns the concept? So what if somebody wants to license the whole thing or parts of it? How would that work? Who would they talk to?
We haven't really applied any patents for the Origo steering wheel, but everyone has their own like IPR and so forth. So they would just talk to individual companies and depending on the technologies and so forth. So
okay.
Yeah.
And maybe I can continue a little bit about the starting point of this project. So we planned that there would be this kind of offerings from multiple companies integrated as a higher level product. And this is one example of that kind of results, that the companies can sell together these concepts.
It's kind of like a showcase of different technologies.
That's great. And then also to let everyone know, so if anyone wants to contact all of these companies, you can go through me, Petra Söderling, petra.söderling@businessfinland.fi. I think a follow-up question is, will there be an Origo 2.0 concept, for example, with haptics included?
I can say first that it's future work, not disclosed, but the companies can decide how much.
Any of the companies want to share your secrets?
Well, technically, yeah, if I may, it's Hasse. Given the haptics technologies today existing, none of them really apply with the design as such here. Those wings and the start and stop module, they are actually a so-called solid part, so they don't float in the design. So if we would take any, let's say, commercial haptics technology, we would need to change a little bit the design to be a floating or moving at some point, which you could actuate, which takes it back to Ahmed's work. So that specifically is designed to, let's say, work with the solid base. So we don't need to create any suspended or floating elements or structures into the stack itself. So at best case, Ahmed's system is able to basically provide a haptic feedback through a solid installation. So remains to be seen how that and when that is in a state that we can showcase it.
Yeah. So if I may add, so not taking directly comment to what comes to haptics, but what we have already have quite a lot of ideas how we can actually utilize this intuitive controls to further make some innovations what comes to the digital user interface and how to use that. So we have a backlog, but let's see what is coming out.
There's always a backlog. Ahmed, do you want to add something?
Just briefly, Hasse has already explained it quite eloquently. The only thing is that, like Hasse mentioned, it's moving haptics in active feedback is a limitation in most of these environments, like in car vehicle. And what we need to, or what we are working on, or we're trying to do, is to bypass these limitations in which if something moves in an environment that's already moving, does it really provide you haptic feedback? So we're kind of trying to go over all of those limitations, but yeah, that's work in progress, and we'll see how that can be shared.
Is that also, Hasse, you mentioned that this was the unique point was this is not reproducible in this form factor. Was that a driver in the design? So maybe there's another form factor if you want to add other features such as haptics.
Yeah, in that context, the thickness of the part is what's kind of considered to be very unique given the features. So we are in the wings itself, they are 4 millimeters thin at total thickness, and within that structure we have all the touch elements. We have the illumination as a system level. Technically, let's say the touch elements are actually on the front side of the part. There is still a possibility to add actually more touch controls into the back side of the part. So we call it as a B film side. So you can do this in a really like a PlayStation style of implementation, that you have a front and back side activations, which are not interfering each other. So they can be made possible as such. But really the unique is the thinness of the part with illumination features, and particularly also the transparent window. So if I look at any other competing technologies, so traditional technologies today, you are probably in about 10 to 15 millimeters thick part with that feature set. So that makes a huge difference in that sense. And in particular, if you add haptic technology, that further increases the thickness of the part. So you are soon to be in a 40 millimeters wing part in that sense. So it is unique in a global domain.
All right, we're actually 55 minutes into the webinar, so let me try wrap up real quickly. One final question: will a cost comparison be done for the concept versus mechanical steering wheel switches?
Technically doable. We are in discussions with some of the steering wheel suppliers, so we can do kind of a head-to-head comparison. Of course, we have to go then back to the feature set. So we cannot take a very, let's say, a base level Toyota Corolla steering wheel, but we have to go pretty much in the high end to do the comparison. But it's technically possible to do, and plan to be so that we actually have a full cost breakdown, or actually total cost of those, for example, wing parts and the start and stop. So you get the functional part cost structure as well. So it is planned to be basically consolidated at some point of time during the fall time. So if kind of requested, we can make it available under NDA, of course. But really the comparison to any other steering wheel is something we need to work with either with the OEMs or the tier 1 suppliers like ZF or Autoliv or Joyson Technologies to basically grasp the baseline, what the let's say a comparable steering wheel would be in a cost comparison level.
Anyone else?
Maybe I can add here a comparison just for cost effective analysis would need to be also done in such a way that it balances the usability and the durability of our design. All three aspects need to be considered. Like Hasse mentioned, that it can't be just with a very low-end vehicle like a Toyota Corolla or a Honda Civic. So it has to be catered to the usability and its durability. And you see that most of the manufacturers are limited by what they can achieve by placing buttons on a steering wheel. And everybody wants to think outside the box. And we think that our proposal is a useful term or a starting point.
Excellent. I don't have any more unique questions, some overlapping questions. For further questions, please email me, first name dot last name, that's Petra, P-E-T-R-A .SODERLING @businessfinland.fi. So either questions to the companies on their technologies or their products, and they have a lot more than we presented today, or questions on the research part and how to collaborate with Tampere University. So I can collect all the connections and then facilitate the conversation further. Thank you, everyone. Thank you, speakers. You were wonderful. Congratulations on the design award win. That is fantastic news. Thank you, attendees. I still want to advertise, this is a series of smart mobility webinars, so please go to the businessfinland.fi page where you found these webinars and sign up to the future ones. We have one coming up on software updates for autonomous vehicles, for example. That should be interesting. With this, awesome. Thank you, everyone. Have a good day and good evening wherever you are.
Thank you.
Thank you.
Bye.